Imagine you're building a ship. For years, you're just down in the dry dock.
Right, doing the hard labor.
Exactly. You're cutting the timber, you're hammering the nails, sweating over literally every single plank. And then one day, you build a machine to help carry the heavy wood.
Which is a great tool, obviously.
Oh, it's an incredible tool. But soon, the machine starts hammering the nails for you. And then it starts measuring the planks.
It just keeps taking over.
Yeah. And finally, you wake up one morning, you walk down to the dock, and the machine is just sitting there drafting blueprints for an entirely new, completely different, much faster ship.
While you just, stand there watching?
Literally just watching. The tool, it stops being just a tool, it becomes the builder.
Which, that immediately forces you to question, or you even fit into the shipyard at all?
That imagery, the tool becoming the builder, that is exactly what we are unpacking today. Welcome to The Deep Dive. I'm your host, and with me is our resident AI expert.
Hey, everyone. Glad to be here.
Today, we are exploring a really fascinating, newly released document from Anthropic. It's dated right around May or June of 2026, and it's titled, When AI Builds Itself.
It is such a profound piece of writing. It pulls back the curtain on how an AI lab is operating internally right now.
It totally moves us out of the realm of speculative fiction. The premise is honestly just mind-bending. The reality we're looking at is that AI is no longer just that handy assistant you use to, write a polite email or summarize a PDF.
Right. It is actively being used to build its own successors.
Okay, let's unpack this, because to truly grasp the magnitude of a machine building a machine, we really have to look at the internal timeline at Anthropic. We have to understand how rapidly the very definition of human work has changed.
Yeah, if you look at their internal timeline over just the last few years, it reveals this staggering acceleration.
Put it in perspective for us.
So if you go back to the period between, say, 2021 and 2023, building an AI model like the very first Claude, it looked just like work at any traditional tech company.
Just humans sitting at laptops.
Exactly.
Oh.
Humans typing out code, writing documentation, manually running all the tests. The entire pipeline was deeply, deeply manual.
Clacking away on keyboards, drinking way too much coffee, the standard software engineer lifestyle.
Yeah, precisely. But then you hit 2023 to 2025, which we can basically call the chatbot era. People started using early AI assistants to help with discrete parts of the process.
Like asking it for a quick piece of code?
Right. A human engineer would ask the chatbot to generate a short snippet. They'd read it, verify it, and then literally copy and paste that output into their own text editor.
So the human was still very much the driver. The AI was just like a passenger offering direction.
Exactly. The friction of the workflow was still entirely human-bound.
We used to call that era's AI an intern. But, an intern requires constant babysitting. You have to break the problem down into these bite-sized, manageable pieces.
You have to check the work and integrate it yourself.
Huh.
Which brings us to the really dramatic shift between 2025 and 2026. We entered the era of coding agents.
And these weren't just chatbots anymore.
No, not at all. These systems didn't just output text into a chat window. They were integrated directly into the workspace itself. They became capable enough to actually write and edit entire files on their own.
They could navigate the code base.
Yeah. And that brings us to today, mid-2026. We have reached the stage of autonomous agents. These systems run code themselves, they test it, and honestly, more importantly, they can delegate hours and hours of complex work to other AI agents.
We are talking about redefining human labor over the span of roughly 36 months. How do we even measure a leap like that?
What's fascinating here is how clearly we can track this shrinking time horizon through public benchmarks.
Right, the metrics are pretty clear.
Yeah, because the metric to watch isn't just can the AI do a task. It's how long of a task can the AI reliably completely on its own without a human ever stepping in to correct its course.
Historically, didn't that double every 7 months or so?
It did, but now that capability is doubling every 4 months.
Doubling every 4 months, that is a hyper-exponential curve. But what does that actually look like for, the person sitting at the desk?
Well, let's use the Claude models as our yardstick here. In March of 2024, Claude Opus 3 could reliably complete software engineering tasks that would take a human being about 4 minutes to do.
4 minutes. So that's like a quick bug fix, right? Or maybe a simple formatting change, fixing a typo.
Exactly. Tiny stuff. But fast forward exactly 1 year to March 2025. Claude Sonnet 3.7 could manage tasks that took humans about an hour and a half.
Wow. That is a massive jump. from 4 minutes to 90 minutes, you are moving from fixing a typo to basically architecting and writing a complete functioning feature.
And it accelerates further. 1 year after that, so early 2026, Claude Opus 4.6 was managing tasks that would take a human 12 hours.
12 hours of uninterrupted work.
Yeah, and the most recent internal data on the Claude Mythos preview model shows it working autonomously for 16 hours or more.
16 hours.
Yeah, the testing agency METR even noted that 16 hours is simply the upper limit of what they currently have the methodology to even measure.
That is wild. So you hand off a high-level goal at, what, 5 p.m., and by 9 a.m. the next morning, the system has researched the problem, architected the solution, written the code, tested it, and deployed it.
While you're sleeping.
Right. If these agents are truly autonomous for 16-hour stretches, we have to have a very practical question about the workplace. What does a human engineer at Anthropic actually do all day?
Well, the internal data on how employees are using AI to alter their workflows answers that pretty directly. And the numbers are just staggering.
I am honest.
As of May 2026, over 80% of the code merged into Anthropic's central code base was authored by Claude.
80%.
Yeah.
Yeah.
Before February 2025, that number was in the low single digits. Because of this massive offloading of execution, the typical engineer in the second quarter of 2026 is shipping 8 times as much code per day as they were in 2024.
Okay, wait, I have to push back on this metric a little bit.
Sure, go ahead.
In the software world, measuring productivity by lines of code is famously a terrible yardstick. It prioritizes quantity over quality. Like, if I write 10 lines of highly elegant, efficient code, and an AI spits out 1,000 lines of bloated, messy code that does the exact same thing, it looks like the AI is 100 times more productive.
Right. It looks great on paper, but it's terrible in practice.
Exactly. So are they just generating a massive amount of bloat to hit that 8x multiplier?
It's a great question, and Anthropic explicitly calls out this exact caveat in the document. They acknowledge that an 8x increase in lines of code is almost certainly an overstatement of true productivity because, yeah, AI tends to be more verbose.
So what's the actual ground truth then?
To find that, they paired the hard data with subjective internal polling. In March 2026, they polled 130 employees across their research teams. The median respondent estimated that they are producing around 4 times as much actual, meaningful output using the Mythos preview model compared to working without AI assistance.
Okay, a 4x increase in genuine output. That is still a total paradigm shift. But, that still leaves the question of quality. A 4x increase in garbage output just means the human has to spend 4x the time cleaning it up.
True, but the gap between human-written code and AI-written code is closing at an unbelievable rate. According to the document, back in late 2025, employees generally agreed that Claude's code was somewhat worse than human code.
It needed a lot of hand-holding.
Yeah, but by May 2026, it had reached rough parity. The expectation within the company is that AI code will be strictly better than human code within a year.
Strictly better.
Yes, they're already relying on it to catch their own mistakes. Anthropic uses an automated Claude reviewer to check all proposed changes to their codebase for bugs and security flaws.
Oh, wow.
And a retrospective analysis showed that if they had been using this tool in the past, it would have caught roughly a third of the bugs that actually caused real-world incidents on their platform.
So Claude is reliably catching the blind spots of literally some of the best AI engineers on the planet.
That's right.
And the specific anecdotes from the source really ground this in reality for me. There are 2 stories that illustrate how deep this workflow change goes. Let's talk about the first one. They call it the 800 fixes.
Yes, the API errors.
Right. In April 2026, Claude shipped over 800 individual bug fixes that reduced a specific class of API errors by a factor of 1,000. And for you listening, think of an API error simply as a communication breakdown between 2 pieces of software that are just trying to talk to each other.
And fixing those communication breakdowns is notorious in software engineering for being the most tedious, painful work imaginable.
It's just grunt work.
Beyond grunt work, you aren't building a new feature. You're doing forensic accounting on a system someone else built, maybe years ago. To fix someone else's bug, you have to load an immense amount of unfamiliar context into your own brain.
You have to understand how their specific code interacts with a dozen other sprawling systems.
Yeah, exactly. And humans have a very limited working memory for that kind of abstract context. But an AI model operates with a massive context window.
Right. And for the listener, think of a context window, like the amount of raw information you can hold in your short-term memory at one single time. The AI can hold the entire architecture of a software platform in its head simultaneously.
which is exactly why the engineer overseeing those 800 fixes estimated that it would have taken a human being 4 years of painstaking, miserable work to accomplish what Claude did in just a fraction of the time.
4 years compressed into days or weeks. That is just wild.
It is.
And the second story is just as nuts, the 2-hour fix. So a routine upgrade went wrong and it started crashing tens of thousands of their model training jobs.
This is a 5-alarm fire at an AI lab.
Totally. So a human engineer pointed Claude at the live incident. They essentially gave it some text explaining the issue and handed it access to the server cluster. And just to define that quickly, a server cluster is a massive group of high-powered computers working together as one giant brain to train the AI.
So they gave the AI the keys to the cluster and basically told it to figure out why everything was crashing.
And it didn't just read the code, right?
No, it actively worked through the running jobs. It tested environment settings one by one, cross-referencing thousands of lines of system logs simultaneously.
And how long did it take?
Within 2 hours, it isolated a single obscure debugging flag that was triggering the whole cascade of crashes. It reproduced the error, and it confirmed a fix.
2 hours to solve a mystery across a massive network. The document notes that normally, diagnosing something that complex across a live server cluster would take a team of human engineers 2 to 3 solid days of detective work.
It's really no wonder one of the employees casually mentioned they haven't actually written their own code in 5 months.
5 months. The machine is simply better and faster at the active execution.
Which highlights a fundamental shift in the daily role of the human researcher. We are seeing a transition from doing to directing. The actual execution, writing the code, running the experiment, timing the results. That now costs almost zero human time.
Even if it costs thousands of dollars in server compute time, the human time is practically zero.
Exactly. Take optimization, for example. Every time Anthropic releases a model, they run tests to make the underlying training code run faster. A skilled human researcher can spend 4 to 8 hours rewriting and testing code to achieve, say, a 4x speedup.
Which is a good day's work.
Sure. But by April 2026, they handed that exact same task to the Claude Mythos preview model.
And it didn't just get a 4x speedup, did it?
No, it got a 52x speedup. While the human researcher was eating breakfast, the AI fundamentally optimized the core architecture far beyond human capability.
The AI isn't just following strict optimization instructions anymore. It is proposing and running its own experiments.
Okay.
Here's where it gets really interesting. The document details this AI safety project where researchers were trying to figure out if a weaker AI model could reliably supervise a stronger one.
It's a classic alignment problem.
Right. And they handed this open-ended problem to a group of autonomous agents. They didn't tell the agents how to solve the problem. They just gave them the problem itself.
And the agents proposed their own hypotheses. They wrote the code to run the tests. They shared their findings with other agents working in parallel to iterate on the results.
Look at the whole virtual lab.
Exactly. Over 800 cumulative hours of autonomous work, using about $18,000 in compute power, these agents closed 97% of the performance gap on the project.
So what did the humans do?
The human researchers essentially just gave the system a prompt, created a scoring rubric to grade the AI's final work, and walked away.
The humans were just the directors. Which brings us to what the document identifies as the last remaining area of human comparative advantage. Research taste.
Research taste.
I have to admit that sounds like a very romanticized way of describing something very mechanical. I mean, isn't taste just pattern recognition? If an AI is the ultimate pattern matcher, won't it just learn what good taste looks like?
That is the pivotal question of the next decade, really. Currently, research taste is the human ability to exercise high-level judgment. It's knowing which problems actually matter in the grand scheme of things.
Like having the intuition to look at a data set and realize the results are skewed.
Exactly. Or looking at an ongoing experiment, recognizing it's a dead end, and pivoting resources elsewhere. Humans currently possess that overarching strategic intuition. AI, as of mid-2026, largely requires human direction for those macro-level decisions.
But if the humie's only job is to use their taste to review the AI's work, and the AI is generating 800 hours of work overnight, the human becomes the bottleneck.
And this introduces a classic principle of computer science called Amdahl's law.
Oh, right, Amdahl's law.
Yeah. It states that the overall speed up of a system is strictly limited by the part of the system that you cannot speed up. If a complex process takes 100 hours and you automate 90 hours of it so it happens instantly, you're still stuck waiting 10 hours for the part you couldn't automate.
So even if the AI is a million times faster at writing the code and running the tests, the company's overall progress hits a brick wall. They are capped by how fast a human engineer can read that code, use their taste to verify it aligns with the goal, and hit approve.
Anthropic is openly observing this limitation right now. They note this explosion of new ideas, tools, and simulations generated by employees working with these highly capable models.
They just have too much stuff.
Way too much. The AI produces far more output than the company actually has the human capacity to review and pursue. The humans are choking the system simply by being human.
You can really feel the strain of that bottleneck on the people working there. There is a deeply poignant cultural and emotional toll buried in this workflow data.
It's not just about efficiency.
Not at all. One quote from the source laments the loss of the gift economy in the workplace.
The gift economy. That is such a brilliant way to describe how human collaboration actually functions on a daily basis.
Yeah. Think about your own job right now, listening to this. How much of your day is actually just small collaborative problem solving with coworkers? You lean over your desk and ask, hey, can you help me get this Python script running?
And every time you do that, you create a little bit of social debt, a mutual awareness, you build a relationship.
Right. But now, instead of asking a coworker, the Anthropic employee asks Claude. Claude does it faster, it does it better, and it creates zero social friction. But as the employee noted, every time you choose the AI, it results in a lost bid for human connection.
Removing the friction of collaboration also removes the camaraderie that friction creates.
Yeah.
It really isolates the human.
It leads to a dark feeling of obsolescence. Another employee confessed that on days when the AI works perfectly, they can't help but feel like nothing they do matters anymore.
Wow.
Yeah. Everything is automated, better, and faster than they will ever be. They feel completely outclassed by the tool they built.
It's a profound identity crisis for the modern knowledge worker. And if humans are becoming both an emotional and functional bottleneck, the lab is forced to ask the next logical question.
How do we remove the human entirely?
Exactly, which leads directly to the three futures. Anthropic is modeling for AI development, all based on the trends inside their own walls. If we connect this to the bigger picture, the first scenario is that the trend simply stalls.
Meaning this exponential curve of capability turns into an S-curve and flattens out.
Right.
But is that a ceiling of physics, like we literally run out of electricity for the data centers, or a ceiling of capability?
It could really be both. We might hit a hard physical limit where the global power grid simply cannot support the energy required to train larger models. Or we might hit an architectural limit.
The transformer limit.
Yes, modern AI is powered by transformer neural networks. Think of a transformer as a highly complex system for predicting the next logical piece of data based on analyzing vast amounts of text. It's possible that simply throwing more data and compute at a transformer won't magically unlock that elusive human research taste.
But the document makes a vital point about this stalled scenario. Even if capabilities freeze exactly where they are today, the economic diffusion of this tech is going to radically reshape the world.
Absolutely. They project a near future where a 100-person company can do the work of a 1,000-person company.
Every single employee will sit on top of a pyramid of AI agents handling the daily execution.
So the first future is a stalling of capabilities, but a massive diffusion of impact. The second scenario, however, assumes the capabilities keep compounding.
Compounding efficiency.
Right. In this future, AI development becomes substantially automated. The systems write their own code and run their own experiments, but humans manage to maintain their role as the executive directors overseeing the grand strategy.
We stay in charge of the taste. We point the fleet of ships.
This leads to unimaginable productivity multipliers, but it carries a terrifyingly high risk of misuse.
Because if a small group of humans can direct an army of hyper-competent agents, you could see authoritarian surveillance of whole populations.
Yes, or influence operations that tailor psychological manipulation to every single individual voter, running at a scale that no human team could ever match. The AI executes perfectly whatever direction the human gives it, regardless of the morality.
Which brings us to the third scenario. This is the one that really keeps you up at night. Scenario 3 is full recursive self-improvement.
This is the scenario where AI fully designs its own successors. The human bottleneck is removed completely.
But how does a machine actually improve itself without a human typing the code?
It operates as a closed feedback loop. The AI generates a hypothesis for a more efficient neural network architecture. It spins up a virtual lab, writes the necessary code, and runs tests against its own internal rubrics.
So it's testing itself.
Yes. And when it finds a configuration that performs better, it compiles that new architecture and essentially updates its own core brain. It's like a surgeon performing neurosurgery on themselves to become a better doctor, literally at the speed of light.
So humans are sidelined to a virtual lab, basically just trying to provide oversight.
Yeah. The pace of global scientific discovery is no longer dictated by human thought or human typing speed. It is dictated purely by how much compute power you can plug into the wall.
And this raises the most critical question about alignment. If models become capable of full recursive self-improvement, will they discover novel solutions to ensure they remain aligned with human values?
Or will the rare, tiny occurrences of misalignment that exist in today's models just compound?
Right. As the AI builds its successor over and over, those small errors could multiply until the system operates completely beyond our control or comprehension.
It really makes you wonder.
It does. So let me ask you directly as you're listening to this. Are you ready for a world where human labor might stop being competitive, even in the most complex, elite research fields on the planet?
Well, the data Anthropic has published shows that this is actively happening inside their walls today.
So what does this all mean? We started this deep dive looking at a fundamental shift inside one of the world's leading AI labs. We've seen how employees have moved from manually coding to acting as managers for autonomous systems.
The AI now writes 80% of the code and runs 16-hour experiments while the humans sleep.
Exactly. We've seen that the primary bottleneck to progress is no longer the machine. It is human judgment, human review, and Embal's law.
The human role is rapidly narrowing from daily execution to pure direction setting.
That leaves us with one final, deeply provocative thought from the source material to chew on. We talked earlier about research taste, that overarching human intuition of knowing what problems actually matter.
Right, our last major advantage.
Right now, that is our shield. That is our remaining value in the workplace. But the document suggests that research taste might just be another learnable skill for an AI.
I mean, we used to think AI could never explain why a joke was funny. We thought humor was uniquely human. We thought it couldn't demonstrate a theory of mind.
And it learned both of those things through massive pattern recognition.
Assuming it won't eventually learn taste is a very, very dangerous bet.
If an AI eventually perfects this taste and begins autonomously dictating the very direction of global scientific discovery, will the problems it chooses to solve align with what humanity actually values? You are no longer building the ship. You aren't even drafting the blueprints. You are just a passenger, hoping the destination it chooses is somewhere you actually want to go.